Hi, this is Professor Stugard, and in this video we're going to talk about the programming concept of iteration or looping and also indexing in the R programming language. So our goals are to first understand actually how indexing works, and we're going to get there a little bit later. We're also going to talk about how the for loop works, and we're also going to talk about, well, hopefully have you think about how we can apply iteration to some of our different types of programming and our different ways of data analysis. So iteration, which is sometimes also called looping or cycling, is the process of writing code where instructions are going to be replicated or repeated. Now, iteration is a large part of all general programming, and there's two main functions that we're going to be using. The for function, which runs for a specified number of loops, and the while function, which runs based on the outcome of some sort of logical condition. And so those are going to be two functions that, again, also appear in every programming language out there because they're basically the keys to, well, iterations and looping. We're going to focus mostly on the for statement for this particular class, but the while statement, it does have its uses as well. So both functions do work in a similar manner. They both require some sort of condition and then some sort of code block or body of code for us to run. So again, it starts, and again, you should see some similarities to like our if statement almost, where we need to have our condition in our parentheses, and that's how our for statement starts. We need some sort of condition. Now, for is going to have a counting condition. It's going to tell me how many times I need to do a particular task, and then the while statement would have a logical condition involved in it as well. Then after we have our condition in parentheses, then the next thing we have is our code in braces or that squiggly bracket, which is the code block that we want to run for however many loops. Now, by default, if we let RStudio start to auto-complete the for function for us, this is what it's going to look like. So again, if you start typing for and then you let RStudio auto-complete it, this is what we get. For, and then parentheses, variable in vector, and then we got our squiggly brackets, which is where we would put our code block in. So let's take a look at the thing piece by piece. So the first one is variable. Now, typically for the for loop, we need to specify a counting variable, and typically we use I. I is typically our first counting variable. Now, if you want to nest for loops inside of for loops, you would use I, then J, then K. You don't specifically need to use I. It's just that that's pretty much the convention. And that's the convention not just in the programming languages, it's also the convention in mathematics and higher level maths. If we do summations, again, usually our counting variable ends up being I. So I is our counting variable. The next thing is in vector. So vector, we need to replace vector now with something. So we can specify the vector portion in a couple different ways, but typically we pick one of the two options. The first would be we set it up and we use basically a colon to separate two numbers. So in this case, 1:10. And what that means is we're going to start our counting variable with the number 1, and then we're going to run through the loop. And each time we run through the loop, we add 1 to our counting variable. So it's 1, we run through the loop, then it becomes 2, then 3, then 4, then 5, all the way till we get till 10. And when we hit 10, that's when we stop running our for loop. All right. So again, if I want to run it a specific number of times, and I know that number of times, this is probably the best way to do it. 1, and then, well, whatever our stopping number is going to be. And in this case, right, we're going to run through it 10 times. The other option, and this is really useful, again, kind of exploring data frames, is using what's known as the sequence along function. So the sequence along function basically means we're going to sequence along or move along our data frame, column by column. So if I want to apply an operation on every column in my data frame, then the sequence along function is the way to do it. So again, sequence along, and we would apply that to our data frame. And again, that's going to tell us to move along our data frame one column at a time. So one other thing we want to be cognizant of is, again, this for loop is going to run and it's going to go through its pattern, but that's not really useful if we don't have some sort of output to go with it. So along with every other function, we want to specify, well, we want an output, and in this case, so we need to specify our output. Now, it is much better to specify our output and define what our output is going to be before we run our for loop. It's not entirely necessary, but it does make our code run much, much faster if we already know what it is our output's going to look like, because we can allocate that space in the computer's memory kind of ahead of time and then just fill in the pieces. All right, and again, doing it that way means that each time the loop runs, it's just adding our data to the output that's already there and not creating it from scratch every single time. So let's take a minute to look at an example and hopefully have it make a little bit more sense. So let's say we have a data frame that is about football prospects. And it looks like every variable, height, weight, age, sprint time, and the max bench press, those are all numerical values. So everything in this data frame is stored as a number. So let's say I want to find the average of every single one of those variables. Now, again, I could basically run through and write the code to find each average one at a time, but that's not super efficient. I want to instead use a for statement, and the for statement is going to allow me to run through it one at a time, find the averages, and let me do it all really with one block of code. So first things first, we need to make sure that we have an output variable to store the results of our for loop. Now, since I want the averages, that's kind of what I'm going to name it. I'm going to name it the pros_average. So that is my output. So I'm creating my output, and I want to tell the computer what to store in it already. So first of all, I want it to be a vector. So again, I want it to basically, I'm telling the computer, create a vector in that computer's memory. Then the next thing I want to type is the data type. So I want a double, right? I want my average to be a double. It's a numerical value. Now in this case, we do want to put it in quotes, whatever the data type is. But again, you could use integers or logicals or even characters. It doesn't really matter, but you do have to specify that data type for that one vector, right? And we're only allowed to use one data type. The last argument is going to be how many entries will be in that vector. Now, again, if you know the specific number, you can absolutely just type the number, and that's fine. Or, again, we can have the code run through, and in this case, well, I want an entry for each one of my columns, which, in that case, well, just use the number of columns in my data frame prospects. So we use our code to find the number of columns to basically put that in there. And again, the really nice part about doing things like this, and not just putting a number, but putting a piece of code in for finding the number of columns, is that this makes my code reusable. I can reproduce it. I can still run this code again, even if the number of columns changes. It's still going to work because I didn't specify a specific number. I specified, hey, check how many columns there are. That's how many entries I want in this particular vector. All right, so I want my data, my output, stored as a vector with the data type double, and I know it's going to be as large as the number of columns in my data frame because I'm going to run through every column in my data frame. So again, I specify what my output's going to be. We need to make sure we do that. Then we run our code. So for, and then my counting variable I, in, and in this case, I want to run my sequence along prospects. So again, run along my entire data frame prospects for each column. And then my code block, I want to fill in my new vector I created, pros_average, with the mean or the average of my prospects in my data frame. Now, what about all these i's, right? So I is my counting variable, and I see a bunch of these brackets with i's as well. Well, we use these brackets for indexing. And what this means is that each time we run through the loop, we're only going to look at the ith entry. So again, it's going to start with 1. So now I equals 1, and we're going to look at the first column in my data frame. We get done running through the code, then I changes to 2. And then we're going to run through the second column in my data frame. And I changes to 3, 4, and then there's 5 columns. So it's only going to run through 5 times and then be done. And again, this makes it reusable. So those brackets are how we do indexing. Now, if I run my code, pros_average, and then I check my answer, sure enough, I have a vector that has 5 doubles in it. We know it's a double because it's got all the decimal points in there anyway, right? Everything is rounded to 2 decimal points. It doesn't necessarily need to be. And if we compare that with my original data frame, yeah, it looks like we did it pretty close, right? The height, 72, 78, 76, 77, 76. And then my first entry in my output vector pros average was 75.8. That sounds about right. And if you look through all of them, they look about right. And, well, it's because they are right, because my code works properly. But let's take a minute to talk about the indexing. So when we run code, indexing assigns a number to every entry in a vector, and it assigns it as a counting number. And the R programming language starts with the number 1. So it's going to count 1, 2, 3, 4, 5 kind of as we go along. Now, some programming languages start with the number 0. The first index is 0, so there's a little confusion sometimes when you're working with a bunch of different programming languages. A quick Google will pretty much settle any questions you might have. Again, we start with 0 because that is a much more mathematical thing usually. So again, some programming languages start with 0, but R starts with 1, which is more intuitive for most students, so that's actually kind of nice. Now, indexing also applies to multi-dimensional structures as well, so like a matrix or a data frame, something that's like a table or tabular data where we have rows and columns. And in that case, our indexing would be described with 2 numbers, basically like an ordered pair, or even like Battleship, like over and up, right? It's the same idea. So, how does indexing work? So I have my output vector, right, that we just checked. Now, if I type my vector, right, if I type my vector by itself, it gives me all the values, but if I put 3 in my square brackets, the way it's going to work is it's going to go through and it's going to look at just the third entry. It's going to count 1, 2, 3. Here's your third entry. Here's the result. 21.2. And it's going to give me that answer, which is really nice. I can pull specific values from my vectors without having to necessarily even know what that value is. I can pull it as long as I know what position it is in, how it's been indexed. So taking a look at this, now I can also return multiple values in a row. So I can return a range. And again, I'm going to use that colon to specify a range. So if I do pros average, but now in my brackets I do from 3 to 5, it's going to say, all right, well, 3, 4, and 5, right? Those in a row, those are the 3 data values that he wants me to pull, so I'm going to give it to him. All right, and so I can even pull a range of values using my indexing. Now, I can also replace specific values in a vector using indexing, which is really, really nice, because I can look at my vector and be like, well, I want to replace just one value. So, okay, it's my third value in this case. So in pros average, in that third value, instead of 21.2, just do 21. I want a whole number. I don't want to add, what's 21.2 years old? That doesn't make any sense to me. Right? We don't talk about ages that way. They're 21. I just want 21. So in pros average, in spot 3, put the number 21, right? And again, 3, 3, the third one matches up. And now when I check my code, sure enough, see that third entry has now been replaced with the number 21 instead of 21.2. And again, we could do that as a quick way to replace any data values that are not exactly how we want them to be using indexing. Now, for the multidimensional indexing, again, basically we're doing it as kind of an ordered pair, except, well, so let's say I run my indexing on my data frame here, prospects, 3, 2. Now, the way it works is that it always goes row, comma, column. So it says go to the third row. So go down to the third row, 1, 2, 3, and then 2. So the second column. So go in 2 columns. All right. And that value, again, in this case is 215 because I can see it, right? If I find it, and when I run my code, boom, it returns my value 215. Just note that it's going to return that as a data frame. All right. When we index our data frame, our output is a, well, data frame. And again, we can create a range with this as well. So I could say, take rows 3 to 5 or so on, right? And again, we can create data frames and index and basically crop our data frames however we would like using our multidimensional indexing. All right, the while statement. So again, the while loop is similar to the for, but there's a conditional statement. If it's true, it evaluates the code chunk. If it's false, it just jumps outside and the loop is never executed. Now, again, it doesn't vectorize well, and it doesn't really have a great place in data analysis, or at least not in an introductory data science course. It is very useful in simulation programming, where you want to keep simulating until you reach a certain condition. but not so much for what we're going to do. So we're going to mostly ignore it, but just be aware that the while statement exists. It is a major part of fundamental programming as just a general concept, and you probably will run across it here and there. All right. Now, again, now that we've talked about control flow and iteration, what we're going to be doing next is we're going to start creating our own functions to complete specific tasks. This is a really important step to becoming a well-rounded developer or analyst who can actually create their own tools to solve the problems they're faced with. So you want to make sure that you're really comfortable with everything up to this point so that you know how to use it and how to implement it in your own code and in your own functions. And that's going to be that should be a real goal for you as we try to finish this course. So now we're at the end though. Can you answer these following questions? So first of all, can you describe the basic structure of a for loop? So again, for example, if you run your code in R and you try to do a for loop, how does it autocomplete, right? And what do you need to put? Next up, if I want to return just the fourth entry in an indexed vector, how could I find just the fourth entry, right? With the brackets and stuff. And then lastly, in RStudio, run that code. What's it going to look like? So I want you to actually go to RStudio, run that code, and tell me what gets stored in the variable X. But obviously, think about what it should be first. What do you think it's going to look like, and does it match your expectations? Hope so. If not, well, you've learned something. All right, that's it for now. As always, take care of yourselves, and good luck studying.